Bismillahirrahmanirrahim. Welcome to the lecture 1, Introduction to Operating System. So in this course we are going to discuss about the basics of the operating system, then main functions of operating system, then computer system architecture, then user interface and file system, types of computer system architecture, then operating system structure, computing environment, and open source operating systems. Let's discuss the definition of the operating system first. An operating system is the most important software that runs on a computer that acts as a intermediary between a user of a computer and the computer hardware. So operating system is a system software and very important software in a system which acts as an interface between the user and other application softwares and the hardware. The important goals of the operating system: execute user programs and make solving user problems easier. So the operating system acts as an interface and over which different applications, different programs, system and application programs, they run on the operating system platform, and they interface with the hardware through the operating system and make the computer system convenient to use. So without the operating system it is very difficult, because operating system acts as an interface and it hides the complexity, and it hides the it provides abstraction at the higher level and hides the complexity at the lower level. And also the operating system is very important in managing the existing hardware efficiently. Let's say like CPU or memory. So these hardware resources has to be efficiently utilized. So operating systems play a very important role in efficiently managing the resources. So everyone knows these basic informations. Examples: Windows 10, then Windows Server 16 server operating system from Microsoft, then Linux, Ubuntu server, then CentOS, Unix operating systems such as SolarEdge, HP Unix. So these are some of the examples of operating system. And of course, like iOS, mobile operating system, and Android. And also another class of operating system is there, that is called embedded operating system. Example: QNX. What are the main functions of an operating system? The operating system is a very important component that manages the memory. So which we would discuss in the chapter number 7 and 8, memory management. Memory management techniques like paging, segmentation, and virtual memory, page replacement. So all these things we will discuss in the chapter 7 and chapter 8, memory management technique. And operating system also manages the process. Process means a program which is running. A program, when it is executing, when it is in execution, then we call that as a process. So the process has to be managed in a system. So operating system manages the process. So this process management techniques we will see in chapter number 3, then chapter number 4, and also chapter number 5. Okay, so how the process are scheduled when they are accessing the central processing unit, how process are synchronized. Chapter number 5 we will see that process synchronization techniques. So these things we will see in the later topics. Then how secondary storage devices such as disk are managed, disk scheduling algorithms we will see. When many processors are sending request, read write request to the storage devices, how the operating system manage these requests. So they have to do some sort of scheduling the request in a specific order. So these things we will see in the chapter 12. And also swap space management, RAID techniques. So all these things we will see in the later topics. Then user interface management. So this is nothing but shell. Okay, so the operating system provides a shell through which the user can interact with the kernel of the operating system. So it can be like using commands or using mouse based point and click system or touch screen, etc., or by voice. Okay, so there are many options through which an user can interact with the kernel of the operating system. So that service is provided by operating system under user interface management. An operating system also provides security and protection, which we would see in chapter number 11. Okay, protection. Example, file access permission, that all these things we will discuss in the chapter number 10, 11. Okay, and also operating system provides supports communication with other machines. So different systems, they can communicate with each other across a network, across heterogeneous networks using the services provided by the operating system. And also operating system plays a very important role in the input output device management. So input and output devices, all these devices can basically controlled and managed by the operating system. So all these are the main functions of an operating system. So most of these functions we would discuss in detail in later topics. So this is a architecture diagram that shows a typical computer system structure. So at the low level we have computer hardware over which exists the operating system. So operating system, inside the operating system, the important program is kernel. The important module we can say is kernel, and over which we have application and system programs. Okay, for example, shell, okay, is a system program. Application program means, example, text editor, database systems, word processor, spreadsheet. These are application programs. Okay, whereas so let's say this CMD. Okay, so this command prompt, this cell basically is a system software. Okay, so for example, I want to create a folder So a folder is created. Okay, so this the user creates a folder through this shell interface, okay, provided by the DOS operating system command prompt. So this is a system software, and spreadsheet, word processor, all these are, we can consider it as application programs. So user can interact uh, basically when a user is using the system, the user actually cannot directly communicate with the hardware, but it has to be uh, passing through the application or system program, and the application or system program should communicate with the kernel of the operating system, and the kernel of the operating system would accomplish the request, whatever request sent by the user, that would be um, answered by the kernel. And for example, if the folder has to be created in the disk, then all the request has to go through a file system, then the kernel, and to the disk storage. So hardware, we know the examples. Okay, these are basic things. Operating system controls and coordinates the use of hardware among various applications and users. So this is what I was telling in the previous slide. Application programs that performs a specific useful task other than system maintenance functions. Example, word processor, database, games, browser, all are application programs. Okay, so system programs, operating system is itself a system program. Then device driver is a system program. So if you have a compiler in the Linux, C compiler in Linux, it is a system program, whereas the Java compiler in the Windows operating system, it belongs to application program. Okay, so if any program is tightly integrated with the operating system, so we can consider that as a system program. So shell user interface. Shell is a program through which the user interacts with the operating system. So basically there are different types of shells are there. So here this is a shell, okay, the desktop. Here using the mouse point and click system, we can create the folder, etc. So this belongs to this category, keyboard icon based point and click system. Okay, and next one is keyboard entered commands. So here basically if you want to execute any task, then it has to be done through some commands. Make the directory, so a folder is created, then remove the folder, okay. So this is keyboard entered command type user interface. Okay, so even in like Linux or Unix operating system, we have this kind of user interface where we have to enter the commands to execute any task. So touch screen also available, and voice commands also available nowadays. So these are the different types of user interfaces through which an user can interact with the kernel of the operating system. So file system basically controls how data is stored and retrieved. So this is very important. Now let's say so let's say this is my desk, right click, So we have some file system, NTFS. So this is an interface through which we can create a folder, we can store the data, we can retrieve the data, we can manipulate the data, store the data. So for that we need some sort of interface. So that interface is nothing but file system. And example for file system are NTFS, FAT32, and in Linux ext3, ext4. So these are the examples of file system. Okay, so when you buy a flash memory, new flash memory, just right click and check. It would show you FAT32, FAT, file allocation table 32, FAT32. You won't have security features in the FAT32. So what you have to do is just right click, and if there is no data, then you can just format. While we format that time, okay, it would ask the file system that we want. We can select NTFS because NTFS has more features. Okay, so we have security features, let's say uh, properties, security. Okay, so these features are not available with the FAT file system, FAT file system. So okay, so it is very important that you know, you aware of the file system. So in Linux also we have some file systems, ext3, ext4. So when you do the lab 1, when you install, so that time you have to select some file system. So you can go for ext4. And while you install the Linux operating system, actually you have to create swap area also. Please remember, for the swap area it is a raw partition, there won't be any file system. Okay, so what is a swap area? That all these concepts you will see in chapter number 12. Also while you do the lab 1, that time also you would understand these concepts. So let's discuss about the computer system architecture. So the system, old computers, they are single processor system. It supports only one CPU, but nowadays the processors come with multiple processing capacities. So we can call it as multiprocessor system. Supports more than one processor, and the processors share the memory, system clock, and the bus. So a system which has more than one processor, and these processors, they share the memory. There is a single memory that is shared by many CPUs, and also the system clock, also a single system clock that would be shared by many CPUs, and the bus that transmit the data and the signal. Okay, so all these things are shared by multiple processors. So we can call these as parallel systems and also tightly coupled system. You can see CPU, many CPUs, they share the same memory, and they share the bus through which they transmit the data and signal. Each CPU has their own register and cache. Okay, so basically this architecture is called multiprocessor systems, okay, or parallel systems. What are the benefits? Throughput. So what is the throughput? Since more than one CPU is running, the number of tasks completed per unit time would be more. It would be increasing. You can complete more number of tasks. Okay, so that is called throughput. Economy of scale, that means in a single system we can have many CPUs instead of having CPUs in different systems. So it would cut down the cost drastically. Then reliability, like fault tolerance. If one CPU fails, the system can go with other CPUs which are in running conditions. So this is called fault tolerance. So operating system structure, next topic. Now let us discuss about the batch system. So batch system means it is a system which executes jobs which are non-interactive in nature. So for example, for example, I have opened this PowerPoint. I can minimize this, then I can maximize, I can close. Okay, so basically this is called interactive system. The system responds to the user request instantly. Okay, so it interacts, we are able to interact with the system and the system is able to respond to us. So these kind of systems are called interactive system. So batch system, basically it's not an interactive system. So you give the users, basically they give some job. For example, they are giving like they are giving some job to a system. Let's say they are giving 100 HTML file, and the user is wants the system to convert the HTML into text file. Let's say that is the job. Let us define that as the job. So basically the user will give the job to the system, okay, through some interface, and okay, and for example the user is giving 4 jobs, and these 4 jobs would be divided into 2 groups, 2 batches. So and the system would be executing these batches in some specific order. So when the system is executing these jobs, okay, the user cannot interact with the system. Okay, so the system would be executing this job and giving us the result, but in the middle we cannot interact with the system. Okay, so such kind of systems are called batch systems, systems which execute a group of jobs, okay, by transferring control from one job to the another. So when the system finishes one job, then it will transfer the control to the next job. So like that it would be transferring the control from one job to another until it finishes all the job without any user interaction. In the middle the user cannot interact with the system. So if you see any kind of system like this, then you can consider that as a batch system. Okay, so what is multi-programming batch system? It is same batch system only, it is non-interactive in nature, but there is a small difference. Okay, what is that small difference? Whenever any system is doing input or output task, IO task, at that time the CPU is not utilized. Okay, please remember, all the systems, when any program is running, okay, that time the program has to use the CPU. But when a program is running, let us say it is a process, okay, so when any input or output task is happening, that time the CPU becomes idle, it is not utilized. So that time, okay, the multi-programming batch systems which are non-interactive in nature, what they do, when the system is executing a job, and when that job involves some input or output task, that time what happens, the system will transfer the control to another job. Okay, so why? Because in order to avoid wasting the CPU time, so the control is transferred from one system to another. Such kind of systems are called multi-programming batch system. Next, let us discuss the time sharing system. So let me explain the time sharing system. Time sharing system, when you compare with the batch system, the time sharing systems are interactive in nature. Okay, what about the batch system? They are not interactive in nature, but the time sharing systems are interactive in nature. Okay, so interactive multi-programmed systems, that means more than one program can run at the same time, in a system. So interactive multi-program system, okay, which switches the CPU between different interactive programs. Each program running in this system will behave as if they are being run independently on several CPUs. Okay, so let us say this is a central processing unit, CPU or processor. Okay, we have many programs running, processes are running, that are submitted by many users from different systems. Okay, so there is a single system. Okay, you just imagine like this: you have a monitor here, you have a monitor, you have a monitor, monitor, so 6 monitors, okay, screens. They are connected to one system unit, one CPU. There is only one CPU system unit, okay, that to which 6 monitors are connected. So 6 users are using a single system. 6 users are using a single system. So all the 6 users, they are submitting, each user is submitting a process, okay, for execution. So user 1 submitting some program, user 2 some program, user 3 also sending some program, and all these programs, if they want to run, they need CPU. Okay, but only one CPU exists. Okay, so what will happen? The CPU would be shared, the CPU time would be shared among all the processes. Okay, the CPU time would be shared among all the processes, and each system, okay, each individual user systems, they would be thinking that they are the one who is using the CPU, and they think that no other system exists, no other system is using the CPU. They are the only one who is using the sharing the CPU, they would be thinking. So in such a manner, there would be very less amount of delay time. Each and every user systems would be getting their fine share of CPU time, so they won't feel that this CPU is shared among many systems. Is it clear to you? Such kind of systems are called time sharing systems. Time sharing system, when we compare with the batch system, time sharing systems are interactive in nature. So more than one process running, and the CPU is shared among many processors. So the system would switch the control of the CPU from one system to another, okay, very efficiently. So each and every system would be thinking that they are running independently. You get the point? So next one is distributed system. Okay, so basically let us imagine there are many systems, they are interconnected by a network. So each system would have their own CPU, memory, system clock and bus. Okay, so they have their own memory, they have their own system clock, they have their own bus, but they are connected to each other by a network. Such kind of systems are called distributed systems. Computing environments. Let's first talk about the virtualization. In computing, virtualization refers to the act of creating virtual version of something, including virtual computer hardware platforms, storage devices and computer network resources. So virtualization is a technology which allows us to create virtual system units, such as virtual computer hardware, hardware platforms, storage devices, networks, etc. So using this virtualization technique, okay, virtual machines are created. So virtual machine is an emulation of a computer system. Okay, so using this virtual machine concept, we can run many operating systems in a machine. For example, this is called Oracle VirtualBox. Most of you know this. So we can call this as virtual machine manager. So using this, we can create a virtual machine. Okay, for example, I want to I want a virtual machine to deploy Ubuntu. Okay, so it's a Linux, so 64. So memory, we are going to create virtual memory, so we have to allocate the size. Okay, so the physical the host memory is 16 GB. So from the 16 GB, so here you can allocate 2 GB for this virtual machine. Okay, and also we are telling that yeah, virtual hard disk has to be created. Okay, so what is the capacity of the virtual hard disk? Okay, so we say let's say we want 20 GB. Okay, what is the format of this virtual hard disk? Okay, then so now we have created a virtual machine. So basically this virtual machine, inside this virtual machine we can deploy the Ubuntu operating system or any operating system, we can deploy. Accordingly we have to create the specific virtual machines. So when we create the virtual machines, automatically virtual hardware resources such as storage, okay, memory, and all the necessary system units are created and supported by this virtual machine. Okay, so this is called virtual machine. Virtual machine is the emulation of a computer system. The layer of software that enables this emulation is often referred to as hypervisor or virtual machine manager. So this is the virtual machine manager. Okay, example Oracle VirtualBox. Similarly, we can go for VMware. Then in Microsoft Windows operating system, there is a inbuilt hypervisor is there, that is called Hyper-V. Okay, so these are some of the virtual machine manager softwares available. So in this slide you can see the virtualization environment. Basically it's like this. We have a hardware. Over the hardware, okay, the kernel would be deployed, kernel of the operating system. So above the kernel there would be system and application programs application softwares. Okay, so basically now here if we want to run many operating system, we have the option here, hardware. Over the hardware we can directly put the virtual machine manager. As far as here actually we have installed the virtual machine manager over the guest operating system, Windows. For example, in my laptop I have installed the Windows, that is the host operating system. So over the host operating system I have installed the virtual machine manager, example Oracle VirtualBox. But but we can directly install the virtual machine manager directly over the hardware also. Okay, so it is more efficient than deploying the virtual machine manager over the host operating system. So no need to get confused. So here what this diagram shows, that the hardware, over the hardware the virtual machine manager, example or Oracle Virtual Machine Manager, Oracle VirtualBox or VMware or Hyper-V can be directly installed over the hardware. So using the virtual machine manager, in the virtual machine manager we can create any number of virtual machines. So here there are 3 virtual machines created, VM1, VM2, VM3. So over the virtual machine we can deploy the operating system, okay, whatever operating system we want, we can install them over the virtual machines. So here you can deploy three operating systems, separate operating system. They would run independently. So each operating system okay, would be having separate virtual machine, and this virtual machine would emulate the hardware of the system. It would provide the virtual infrastructure, a system infrastructure. So each virtual machine would be functioning as a separate system, using the virtual hardware infrastructure that they have created with the help of the virtual machine manager. Okay, so this is very useful, and this is the fundamental idea behind the concept of cloud computing. So cloud computing environments composed of traditional operating systems, virtual machine managers, and cloud management tools. Okay, softwares that are necessary for the configuration of deployment and configuration of cloud computing. And of course network connectivity is needed, firewalls are needed, load balancers are needed to distribute the traffic according to the load. Okay, so this diagram shows a typical cloud computing environment. So basically the cloud service providers, in their premises, they would have many virtual machines. So they have hardware infrastructure. So using the hardware infrastructure, using the virtual machine manager, they create many virtual machines, and they create virtual storage units, and basically they have the cloud management tools, etc. And this cloud computing environment is supported by firewall for security, okay, and also load balancers. So basically this diagram shows a typical cloud computing environment. So cloud computing basically delivers computing, storage, even application as a service across the network. So it makes use of the virtualization. So that's why here it's given logical extension of virtualization, since it uses the virtualization as a base for its functionality. Example, Amazon, then Microsoft Azure. So all these are the examples of cloud services. So example, Amazon has many servers, millions of virtual machines, then petabytes of storage available, and when the user uses the services, they have to pay. And the cloud computing environment can be classified into public cloud, private cloud, and hybrid cloud. So public cloud means basically the service is provided to the public in general. So you can see here, public clouds are the most common cloud computing deployment. The cloud resources, example servers, storage, are owned and operated by a third party cloud service provider. For example, Microsoft Azure or Amazon, they provide the cloud services. What kind of services? So we can buy a system, cloud system, a server, and necessary hardware infrastructure. Then we can buy the operating system. Then we can buy the um, application development environment, okay, APIs, okay. So and also we can consume the services provided by them, okay. So with the public cloud, all hardware, software and supporting infrastructure are owned and managed by the cloud provider. Example, Microsoft Azure or Amazon. In a public cloud, okay, we share the same hardware, storage and network devices with other organizations. So maybe for example, we buy a cloud service from Amazon or Azure. Similarly, another person also would be buying the service from the Amazon or Azure. So basically, we people, the public, are sharing the hardware resources, okay, or storage resources, network resources provided by the cloud. However, the cloud service provider would provide a isolated environment within which each and every tenant or within which each and every client would operate, giving full security, privacy and confidentiality for each and every client. So there are many advantages like lower cost. When we use the public cloud, the cost would be low. No need to worry about the maintenance, it would be taken care by the service provider. Unlimited scalability, so whenever the demand increases, okay, the we can scale up the service also, like we want to scale up the network system resources, okay, it can be increased based on the demand. And there is a high reliability, the downtime would be less, okay. So this is nothing but cloud public cloud computing. Private means cloud consists of cloud computing resources used exclusively by one business or organization. So a cloud service dedicated to a specific organization or to a business entity. So sometimes the private cloud can be physically located at your organization on-site data center, or it can be hosted by third-party service provider. So basically, the private cloud service cannot be accessed by everyone. It is specific to a particular company. So for example, the employees of a particular company can access the services, okay, or the branches of the particular organization can access the service. So that kind of service is called private cloud computing. Here basically the security is given more priority. Advantages of private cloud: more flexibility. Your organization can customize its cloud environment to meet specific business needs. So the service can be tuned according to the specific requirement of an organization, and the organization has more control over the service, okay. And also, even though it is a private cloud, private clouds often offer more scalability, because suppose let's say a organization has the infrastructure on its premises instead of cloud environment, then the scalability would be a big issue. However, using the private cloud, that issue is solved, okay, because it gives more scalable provision. Then hybrid is nothing but the organization as a private cloud. However, for some reasons it wants to use the public cloud also. Okay. So such kind of cloud computing is called hybrid cloud computing. A hybrid cloud platform gives organization many advantages such as greater flexibility, more deployment options, etc., security compliance. Okay. So it's like, you know, interlinking the public cloud and the private cloud. A hybrid cloud is a type of cloud computing that combines on-premise infrastructure or a private cloud with a public cloud. So it is a way of connecting the private cloud with a public cloud. Mostly organization, when demand increases, when they want to scale up the services, when they want to scale up certain resources, what they do, specific resources they would consume from the public cloud services, and most of the services would be they would provide as a private cloud, but specific services specific resources they take from the public cloud. Okay. So such kind of computing, where cloud computing where public and private or blended is called hybrid cloud computing. So what are the advantages? Control, organization has more control. Okay, flexibility, cost effectiveness. These are some of the benefits of this thing. Okay, and also the services provided by the cloud computing can be classified into SaaS, PaaS, and IaaS. Software as a service, platform as a service, infrastructure as a service. Now the types of cloud computing services. Software as a service, softwares that are available via a third party over the internet. Example, Google Drive, Dropbox. Okay, so these kind of services which are available over the internet provided by the third party can be considered as a software as a service. So any applications which could be used by the client would be provided by a third party service provider, and this service is consumed by the client. Next, platform as a service. The tools, basic tools which are necessary for the development and deployment of software applications would be provided by the service provider, and these services are consumed by the client. Infrastructure as a service, cloud-based services like storage, networking, and virtualization. So these services comes under the infrastructure as a service. You want to buy a server, then you want to create a virtual network among some systems, a virtual network. So all these things comes under the infrastructure as a service. Now you want to develop some application. Basically, for that you need some set of APIs and software development framework. So when any third party provide these APIs and software development framework, then that comes under platform as a service. Okay. Now the software is developed, the infrastructure is in place, the software is developed and deployed, and that application is given for the clients to access. And if the client consume the services, application service, then it comes under the software as a service. Next one is real-time embedded systems. A real-time system is one that must process information and produce response within a specified time, else risk severe consequences including failure. For example, if you take your mobile phone or the laptop or desktop, when you switch on, it might take some time to boot and run the applications, run the operating system, and also when you invoke a specific application, okay, there sometimes there would be some sort of delay. So when an application is running, when you make a request, there might be some sort of delay sometimes. That delay is accepted as far as the our desktop or laptop or mobile devices. However, as far as the real-time systems are concerned, such delay is not accepted, and sometimes that kind of delay can be considered as a system failure. It would produce a severe consequences. Okay, example where these real-time operating systems are used are ABS, aircraft control, temperature monitor in nuclear power station, ECG or arrhythmia monitor. So these are very critical applications where the delay cannot be tolerated. If any delay occurs, then it would produce a severe consequences, especially for example here in the case of this, the patient might die. Okay, here also the passenger might die, and it might create a big accident as far as the aircraft control is concerned. A nuclear power station, these are very very important critical units where time delay cannot be accepted. So such kind of operating system which doesn't tolerate any delay is called real-time operating system. Example, free RTOS, QNX, etc. So basically now we are using my system, laptop is using Windows 10. So we have to pay money, okay, because it is a proprietary software from Microsoft. We have to pay money to buy this application. And also when we want to use any Microsoft Office, we have to pay money and buy the software. If you want to buy any antivirus like McAfee or Kaspersky, we have to pay money and buy, okay, because they are proprietary software, and they are covered by the license issues. So in order to honor the license agreement, we have to pay money and buy the license. But contrary, open source basically allows us to get and use the softwares basically without paying any money, free of cost, free and open source. So free and open source, basically FOSS based operating system, we can even get the source code of the operating system also. We can see the source code, we can make changes in the source code, basically. So these provisions are available through the free and open source operating systems. So operating system made available in source code format rather than just binary closed source. So if you take Windows operating system, we cannot see the source code. We get a binary closed source, and we can just execute and run and feel the operating system, but we cannot see the source code of the Windows operating system. So basically free and open source operating systems, basically they are counter to the copy protection and digital rights management movement. started by Free Software Foundation, which has copyleft GNU public license. So basically, free and open source operating system allows us to see the source code, and we can make the modification, and we can relaunch the operating system with some agreement, with the minor agreement. Okay, basically examples of free and open source operating systems are GNU Linux, BSD Unix, etc. Okay, with this I conclude the lecture 1. Thank you very much. So please refer to these textbooks, Operating System Concepts with Java, 9th edition, Silvergat's J. Gavin and Gigagan John Wiley. And also you can refer the Tenenbaum 4th edition. Okay, Modern Operating System Concepts. Thank you very much.